So for this homework video guide, we need to evaluate the following limits, and for the first few problems, we need to apply the properties of limits. So for these kind of problems, anytime you see the limit sign, basically that needs to be distributed to every single term that you see. So there's 3 terms on the numerator, and there's 2 terms on the denominator. So basically, we have to use a lot of distribution here. And if I show you how to distribute the limit sign onto the numerator, it will look like this. The limit as x approaches -1, and then we have x to the power of 4 minus the limit as x approaches -1 of 5x squared. And then finally on the numerator there's a plus, and then we have the limit as x approaches -1, and we have this constant here. Okay, once in a while when we're looking at these limit problems, if you're given a constant here like we have over here on the second term here, the 5x squared, you can definitely move that 5 to the outside, and then you just have the x squared remaining. And if we distribute the limit sign onto everything on the denominator, we have the limit as x approaches -1 of x plus, and then we have the limit as x approaches -1 of plus 3, so just a constant of 3 there. Okay, and then from there on, all we're doing now is we're taking the -1 and we're applying a direct substitution step here. So the -1 will substitute for every single x value there. And if we start evaluating, if I start looking at this term here, that's simply going to be -1 to the power of 4 minus 5 times, and then we have -1 squared, and then plus, and when we have a constant, we just leave that constant alone as a +1. And then on the denominator there, I guess we're just plugging the -1 all over again into the denominator there, so -1, and then we have a +3. Okay, and then from here, we're just evaluating here, so -1 to the power of 4 is going to be 1, minus 5 times +1, which is -5, and then we have a +1, all divided by -1 plus 3, which is going to be +2 there. Okay, so if we evaluate the numerator there, -5 plus 2 is going to be -3, so -3 over 2 is your final answer for question number 1. Okay, let's move on to question number 2, where we need to apply the limit properties. Now, whenever we have a square root, the square root is on the outside here. And basically this limit sign right here will distribute to all 3 terms inside the square root sign. So if I write my limit statement here, this will be the limit as x approaches 2 of 5x squared. And then we have plus the limit as x approaches 2 of 4x. Oops, put that in blue there, of 4x. And then we have a minus limit as x approaches 2 of just a constant of just 1 here. Okay, and then we'll extend that sign there. Okay, and just like the previous question there, if I have a constant here, the 5 and the 4, we can move those constants to the front. So now I have just an x squared here, and I can move this constant over here as a 4, and then I just have a single x here, and then there you go. All right, so let's go ahead and evaluate this now. So cube root sign. Okay, and anytime we see an x, we're doing a direct substitution step here, so all the x's get replaced with 2. So now we have 5 times 2 squared, and 2 squared is going to be 4, plus 4 times, and then we have, if I substitute 2 for x, that's going to be +2, and then just subtract the constant there at the very end. And if we do the math here, we get 20 plus 8, which is 28, minus 1, which is 27. And the cube root 27 is going to be 3. All right, so there are a few of these limit property questions to kind of start off the homework video guide. And let's move on to example number 5. And for example number 5, we're given a few limit statements right here to start. And we need to evaluate this particular problem where the limit sign is on the outside, and we need to distribute that limit sign into every single term in the brackets there. Okay, so what does that look like? If I distribute the limit sign into the brackets, I have the limit as x approaches a times f of x plus 3 times the limit as x approaches a, and that's going to be multiplied by g of x. And then finally I have a minus 4, so that'll be the minus of the limit as x approaches a of the constant 4. Okay, so that's what we do first. We distribute that limit sign, or that limit, the limit sign into the brackets. And then if I take a look at this limit statement right here, we notice that it matches this limit statement right there. So this first part is going to be 3 plus 3 times. And then we notice that this limit statement right here matches up with that. And that gives me a negative 2. And then we have a minus. And then this part right here is simply going to be minus 4 because that's a constant, right? Okay, so this will be 3 minus 6 minus 4, which is going to be negative 7 as a final answer there. All right, so most students can get negative 7 pretty quickly, but we just need to distribute that limit sign correctly because we're being asked to use limit properties. Okay, moving on to the next one here. If I have a question like this, I guess we have a square root. So whenever we're given a square root, the square root sign kind of takes over everything, and then this limit sign right here will get distributed inside the square root. So we have the limit as x approaches a, and then we have a constant here of 1, and then minus the limit as x approaches a of f of x times the limit as x approaches a of g of x. Okay, and then what we need to do now is we need to do a substitution step here, then we should be good. If I take a look at this limit statement right here, that's just a constant, right? So if we go ahead and finish this off, that's going to be a 1 minus, and then this part right here, if we match this up to the original question here, we get 3, right? So this will be a 3. And if I match this part up with what's given in the problem here, I multiply that with negative 2, right? Okay, so this will now be 1 plus 6, and that will be the square root of 7 as a final answer for that question there. Yeah, so these questions aren't too bad. You just have to apply the limit properties, and it's mostly distributing. So in this case, we have a limit sign, and we can distribute that onto the 2 terms on the numerator, and we can distribute that onto the denominator. So if I go ahead and distribute the limit sign, I get limit as x approaches a, and I have f of x plus the limit as x approaches a, and then we times that by 1, all divided by the limit as x approaches a of g of x. And all of this is being squared. All right, so that's how you apply the limit signs into the numerator and the denominator. And then now we just kind of substitute what the limit's equal to. So this part right here on the numerator, that's going to be equal to 3. So 3 plus, and then I have a constant there, so 3 plus 1 divided by, now g of x is going to be negative 2, right? So that'll be a negative 2 all squared. Okay, so there you go. This is 4 on the numerator, and negative 2 squared is going to be 4, so this will be positive 1. Okay. All right, and I guess we have one more limit statement question here. Let's go ahead and distribute this limit sign here. So what we're going to do here is there's the x cubed, so we can leave that in front. Actually, no, we'll just distribute the limit sign into here. So limit as x approaches a times by the limit as x approaches a of f of x. All right, so that's how we distribute the limit sign into both terms there. So one for the x cubed and one for f of x. Okay, so this right here, we just apply a direct substitution step. So x goes for a, sorry, x gets replaced with a up, so that'll be a, oops, that's going to be a cubed times, and then we have this part right here, which is going to be this right here, so that'll be 3, so 3 times a cubed is going to be just 3a cubed. Okay, I think we're going to finish off this homework video guide with a few direct substitution questions here. So for the next few homework questions, we don't need to apply the limit properties. We can go right into a direct substitution here. So anytime we see an x, that gets replaced with 4. So this will be 4 minus 1 times 4 plus 1. So that'll be 3 times 5, and 3 times 5 is going to be 15. So 15 is the answer for the first limit there. And most students prefer to do limits like this, just a direct substitution here. So this will be 3 cubed minus 2 times 3 squared plus 4. So 3 cubed is 27 minus 2 times 9 plus 4, which is 27 minus 18 plus 4. And if we go to our calculators there, I believe that's going to be 13. Yeah, this will be 13. Okay, so 13 is the final answer for question number 2. And then for question number 3, once again, we're just doing a direct substitution here. So no problems when we have a 0 here for the numerator and the denominator. So there's a 1 on the numerator and 2 on the denominator there. All right, so question number 4, let's change all the x's with 2. So if we do that, we get 2 squared, which is 4. So 4 minus 4 on the numerator and 3 on the denominator. So 0 divided by 3 is going to be 0. Okay, so as we go on to some more limit problems, we're probably not going to be using the limit properties, but we're going to be using a combination of direct substitution and some algebra techniques. All right, so that concludes this homework video guide.